RValue is a familiar measurement when considering the performance of traditional insulation. But when it comes to insulative coatings, RValue isn't as useful. The more important performance value for coatings is thermal conductivity, or KValue. In this episode, we'll discuss the difference between RValue and KValue. Thanks for joining us today for this edition of Coatings Decoded. I'm Mark Thomas with Tennemic Company, and today I'm joined by Peter Pescatori, Global Business Manager for Cabot Aerogel, and also Andy Hoffman, who's a Sales Director at Tennemic Company for Insulation and Specialty Products. Welcome, gentlemen.
Thank you, Mark.
So today we're talking about some of the things that contractors, specifiers might need to think about in terms of insulation and specifically insulative coatings. And I'd like to start out by talking about some of the performance attributes of insulation products. And we hear a lot about RValue. It's something I think is familiar to most people that have gone through a hardware store and they've looked at traditional insulation you might use in your home or business that has an RValue. Can you describe what an RValue is and how it applies to insulation?
Sure. So RValue is a measurement to provide an indication for how much total insulation you have. And it's a combination of how thick a material is present and its material property, referred to as thermal conductivity. So those two values in combination allow you to determine what the RValue is.
Okay. And then we hear also, besides RValue, KValue. And can you describe what KValue is and how that differs from RValue?
So KValue, or thermal conductivity, is an intrinsic material property. So it's something that's inherent in whatever material it is that you're working with and can be measured. And there's standard tests out there that can measure it and determine its property. And that doesn't change no matter what its thickness is. So it has a certain material property. Think of it like density. It has a certain material property, but I could have more of it and it would weigh more. Thermal conductivity would be similar in that, or KValue would be similar in that regard. RValue then would take the thickness and would divide that by that material property of thermal conductivity, and that's what determines the RValue. So it is the combination of the two.
Okay. So at least in my mind, when I'm walking through the hardware store and I'm looking at something with an R19 versus something with a greater RValue, the greater RValue is thicker versus a KValue, which remains constant no matter the thickness. Is that right?
Well, if you're looking at the same material, right? So if you're walking through the hardware store and it's all fiberglass, then it says R13 or R19, likely the only difference between the two is the thickness, where the thermal conductivity would be identical, or the K factor would be identical of those two materials. One is for 4-inch studs and the other is for 6-inch studs. And that's the difference there. Okay.
So why is KValue a better measurement for insulative coatings than RValue?
So the way I think about it is, typically, if you're thinking about using a coating, you're putting it in places where maybe you can't insulate, right? So if you're doing the walls of your home and you have inches of space, you're going to put in fiberglass, or you're going to put in polystyrene or whatever, or you're going to mineral wool or whatever the case might be, because you have so much space that's available to you. There, RValue makes all the sense in the world. But if I'm going onto a surface now that's either hard to insulate or has no insulation, the better the thermal conductivity, or the lower the thermal conductivity, and that's what makes it better, is the lower the value, the better. The better the thermal conductivity, the better the insulation properties of that material. And I don't need as much of it to get the same level of insulation.
So this would be a case of where you need some type of insulation, but for whatever reason, whether it's just a practical installation reason, or maybe just the shape or location of a vessel, or whatever you're trying to insulate, that you're wanting some insulation, but you can't necessarily put on a lot of thickness, which would be more applicable to RValue. Is that right?
In general, that's right. Or it could even be that you could put on more thickness, but you're worried about corrosion on that surface. So you want to make sure you don't have a risk of water getting through. So a coating definitely would give you better performance in that regard. So it's not just about the insulating value. It could be about how you're protecting the surface that's under there, but definitely an odd surface that's hard to insulate with a flat board or a flexible mineral wool or something like that, and putting a coating on, you're really concerned about what the thermal conductivity of the material is, because that is an indication of how well it's performing.
Okay. And with KValue, because people aren't as familiar with that, can you just describe how that might be represented as the information that somebody should be looking for?
Sure. So I'm kind of using KValue and thermal conductivity somewhat interchangeably. I mean, thermal conductivity is sort of the more general term, and KValue usually is when you're putting things in the English system. So it's typically measured in BTU, inch per hour foot squared degree F, as opposed to watts per meter degree Kelvin. So often when people hear KValue or K factors, they're thinking in terms of those English terms. And then those are measurable properties, again, that you can do standard tests and determine what the material properties are for that.
Okay. So assuming that you're looking at two different insulative coatings with KValue reported and it's being reported the same way, how would you know between those two which one has the better, more effective insulative value?
Sure. So again, it's KValue or thermal conductivity. And I think a good analogy is to think of it like electricity. The more conductive a material is, the easier it is for electricity to pass through it. Same thing in heat transfer. The more conductive a material it is, the easier it is for heat to pass through it. So a higher value of conductivity means it will let more heat pass through it for a given volume or size. So in this case, when we're talking insulation, you want lower values of K factor or thermal conductivity, because that means it is better at inhibiting the flow of heat.
So Peter, I'll often get questions from contractors in the field. I'm looking at a couple of different insulative coatings. If I strictly look at the thermal conductivity or K factor, as you call it, I can use those to compare, which product is more efficient than the other. So, for example, if one product's thermal conductivity is 50 and another one is 100, I mean, can we say you would need twice the coating thickness for the product at a thermal conductivity 100 versus the one of 50 to achieve the same insulating properties on a job?
That's exactly right. So if you, in your example, had one that's a difference of 2, you would need half the thickness with the lower thermal conductivity material to achieve the same total insulation value, or R value, in your insulation system.
And so with all manufacturers pretty much listing thermal conductivity on their data sheets, I mean, it's a really quick reference for contractors, architects, or owners to quickly gauge, which product is going to be most efficient for their need.
Absolutely. And it's one piece, right? So again, the total insulation value is a combination of that thermal conductivity and its thickness. So you also have to consider how thick can I put that down? So if I have a coating that can only go down 10 or 20 mils thick, even if it has a better thermal conductivity, I might have to put so many coats of that on before I have enough total true insulation value for it to make a difference. Conversely, if I have a material that has a low thermal conductivity and can go on thicker, then I kind of have the best situation and I need less coats to get to a higher thermal benefit.
So Andy, it sounds like a contractor who's approaching an installation job, insulative coating project, that K value of each product that might be considered and potentially quoted on that project is going to be really critical, because a lower K value means a more efficient insulative product and potentially fewer coats than something at a higher K value. So lower would mean less material potentially being used on the project, potentially fewer coats applied, so labor savings. And how would a contractor know exactly how much material would need to go on that project when they're trying to quote that out?
Well, that's a good question. And that's where we always, request, conditions from a project, whether if it's a job for condensation control and we know the service temperature, that's sweating, the air temperature, humidity, we have a modeling program we can plug that data into, and then we can kind of estimate what that service temperature will get to at various coating thicknesses in relation to the dew point. So it's really important to get accurate field data, and the more accurate that data is, the more accurate of a model we can present to the customer.
Now we're trying to clear up some of the confusion between R value and K value. Hopefully we've helped with that a little bit during this session. But also we encounter something called RValue Equivalent. And can you describe a little bit what that means and how that might translate to insulative coatings, or does it even translate well to that type of material?
Sure. So typically when someone talks about RValue Equivalent, it often means that they have formulated their solution in some way to maybe reflect, say, incoming sunlight. Right. So it might be that in a condition where something is sitting out in the sun, if it's reflecting a lot of that energy back, it could perform as if there was more insulation than there really is. But then when nighttime comes and the sun isn't there anymore, it's not in effect anymore. It's kind of the equivalent to if I put sunscreen on and go out on a hot summer day, it might prevent me from burning my skin, from overheating and things like that. But come night, when the temperature cools, it's not going to keep me warm.
So really, that's not necessarily a true measurement of the insulative value of a coating material then.
No, it's because it's often very dependent on its specific condition. Like I said, it could be a low emissivity coating that it's reflecting sunlight. And so when the sun's out, maybe it does have an impact as if there were more insulation there. But when the sun is not there, it's a cloudy day or rainy day or whatever it might be, it's not providing any true insulation. Because again, true insulation comes back to thermal conductivity and thickness, and there's no way of escaping that.
Okay.
And so Peter, you talk about this RValue equivalency, and when the sun's out, so even I guess that would be impacted too if the surface was dirty.
But certainly a material could perform a certain way when it's applied new, because it might require it have a certain color, certain level of cleanliness and condition, even a certain surface roughness associated with it. And then if it gets covered in pollen or whatever might be around there, suddenly it's not going to behave in the same way as the performance you had at the beginning. Where when you're talking intrinsic material properties like thermal conductivity, if that coating got covered in dirt or pollen or whatever it might be, it will have no impact on its performance.
Sure.
Okay, so we've established that KValue is what should be focused on for insulative coatings thermal performance, and a lower KValue means that it's going to resist thermal conductivity better, so it's going to be more efficient. So looking at those, when a contractor is evaluating different materials for a project and looking for that lower KValue, that's going to be an obvious thing to key in on. But Peter, describe a little bit about how a formulator or manufacturer of insulative coatings might select different types of insulative particles that would impart potentially a lower type of KValue.
Sure. So, I look at a coating as being a composite, right? It's not one material. It's a combination of a number of materials, and you have to put the right combination of materials in there in order to achieve a low thermal conductivity. And the best way to do that is to be adding in additives, solid materials that have very low thermal conductivity. So for example, some people will use ceramic beads or glass beads in their coating formulation. And those beads will definitely improve its performance compared to its baseline. But there are materials out in the marketplace, and one example of that is the aerogel from Cabot that are much lower thermal conductivity. So when we talk about what the additive is really doing for you in that composite, the lower the thermal conductivity of my additive, the better the overall performance of my composite would be, assuming I put the same loading in there. So aerogel allows you to get to much lower thermal conductivity values than a ceramic bead or a glass bead would allow.
Okay, so that KValue is really driven by the type of insulative particle that's used within the coating.
It's driven by that and how much of it you put in, for sure. So if you just put, this isn't magic dust. You can't just put just a little tiny little bit of it and have it suddenly perform as if it were inches of fiberglass insulation. But if you put the same level of loading, then the better the thermal conductivity of the material you're adding in there, the better of the thermal conductivity of your composite.
Okay, very good. Well, Andy, in closing, can you just describe some of the uses of insulative coatings what types of projects a contractor might be exposed to an insulative coating and need to quote on that for a potential bid?
Yeah, sure. The biggest market we've seen is condensation control. You got a sweaty surface. Obviously, moisture is involved, where traditional insulation doesn't generally play nice with moisture. That's where you get your corrosion under insulation. So that's where a coating system with a good corrosion resistant primer and your insulation coating bonded directly to that primer, where we kind of tailor the thickness to the environment. Again, if we know those parameters of the surface temperature, air temperature, humidity, we can design that coating thickness specific to that project to greatly reduce the condensation concern. And then in that case, we can apply a top coat that can be color coded. If it's a pipe gallery, you can color code your pipes. When we talk about the conditions in an environment, it's also important to note, we have little sensors available where a lot of times it's hard to know what your air temperature and humidity is in the space. So we can provide little sensors which can be set in that environment. Go back a couple of days later, and we've downloaded the exact air temperature and humidity in that space. It takes out that guesswork in the modeling program and just makes sure the thickness we're designing is specific to the conditions in that space, and just makes a lot more effective estimate. Personnel protection is another big one. That's where just generally a coat or two of an insulation coating that uses aerogel is going to be enough to provide that safe touch protection. So you don't have to go try to wrap something with a couple inches of insulation and cladding, where you can just, again, apply a thin film coating system, maybe 50 to 100 mils to get that personal protection, that safe touch surface. In the architectural world, thermal breaks are a big one too, where, you got your penetrating steel, whether it be steel supporting the canopy, running, through the wall of your building envelope from interior to exterior, and we can use a coating system there in lieu of structural isolator pads. So it can be a lot easier application, be done in the field or the shop, and it's pretty simple and cheap solution to address that thermal bridging concern. I'd say those are probably the three biggest areas where we've seen the insulation coatings be a really, really nice fit.
All right. Well, thank you. Well, gentlemen, I appreciate your time today. Hopefully this was helpful for contractors and specifiers that might be encountering coatings and insulative coatings on their projects. And I appreciate your time. Thanks for joining us.
Thank you.
Thanks, Mark.
When selecting an insulative coating, KValue is a more accurate performance measurement than the more familiar RValue, which indicates a material's thermal resistance. The insulative particles used in coatings have a great effect on the KValue, so careful examination of the product information is necessary to make the best selection for your project.